In this video, we are going to solve some problems based on the topic of states of matter. So it will include how to calculate pressure, how to calculate pressure in fluids, gas laws, buoyant force, Archimedes principle. These are the topics which we will cover in this video. The first problem is asking you which of the following represents the absolute zero for temperature. Now, absolute zero is the temperature at which molecules stop moving. So that temperature is negative 273 degrees Celsius or 0 Kelvin, and we need to memorize these numbers, and we need to know the unit also. So 0 Kelvin or negative 273 degrees Celsius. If the weight of cylinder in this diagram is 5 Newton and the cross-sectional area is 2 meters square, what is the pressure exerted by the cylinder on the surface? So we are going to use the formula P equal F over A. The force is given, the area is given. We can directly calculate the pressure as 2.5 Pascal. So the unit for pressure is Pascal. Now this page is based on gas law, Boyle's law, Charles' law, Gay-Lussac's law. So let's look at the question and then choose the appropriate formula from the formula sheet. A nitrogen gas has a volume of 0.022 meter cube at a pressure of 10,000 Pascal. So we have got V1 and we have also got P1. It is compressed at constant temperature. So temperature is constant. If the new pressure is 9,000 Pascal, so we got P2 which is 9,000 Pascal, what is the new volume? So we know that constant temperature means we are going to use Boyle's law, which says that P1 V1 equal P2 V2. Just substitute all the numbers and use the calculator to get the value for V2, 0.024. Do not forget the unit for volume is meter cube. It's also given in the question itself. You can see that volume unit is meter cube. Next problem, a gas of volume 6 liter at a temperature of 20 degrees Celsius. So the volume is given to us as 6 liter. Temperature is given to us as 20 degrees Celsius. Now remember, in gas law, the temperature unit must be Kelvin. So if they give you in degrees Celsius, you have to convert that into Kelvin by adding 273. So you get it as 293 Kelvin. If you don't convert, you will get a wrong answer. So temperature must be in Kelvin. Then we can read further. It says it is compressed to a volume of 4 liter at constant pressure. So pressure is constant. What is its new temperature? They are asking us to get the new temperature. So we'll use the formula V1 over T1 equal V2 over T2 because the pressure is constant. We substitute the numbers and then we get the value of T2 as 195 Kelvin. So that's the answer which we get, 195 Kelvin. It is in Kelvin. If you want to convert that into degrees Celsius, then you have to do 195 minus 273 to get the final answer as minus 78 degrees Celsius. Now you don't have to convert in degrees Celsius unless the question is asking you to get the answer in degrees Celsius. But always remember, if you want to substitute into the formula, the temperature must be in Kelvin. Okay. Next, a gas is at a pressure of 2 times 10 power 5 Pascal at a temperature of 270 degrees Celsius. So we have got the pressure and temperature which we can write down. At what temperature will the gas pressure increase to 3 times 10 power 5 Pascal? Okay, so before that, as I said, degrees Celsius needs to be converted to Kelvin. So you can see that 270, I'm adding 273 to it to get the temperature in Kelvin, which is 543 Kelvin. Now the new pressure is given to us 3 times 10 power 5 Pascal. Volume is constant and they are asking us to get the temperature. So we are going to use the formula P1 over T1 equal P2 over T2. And then we just substitute the numbers which we have already got. I'll again check you are substituting temperature in Kelvin. So I'm putting 543 Kelvin here. And then I get the answer for T2 also in Kelvin. If the question asks you to go ahead and convert this into degrees Celsius, then you have to do minus 273 and your degree Celsius answer will be 541.5 degree Celsius. Next, we want to find pressure in fluids. A liquid of density 1020 kilogram per meter cube is poured into a container to a depth of 0.3 meter as shown below. What is the pressure exerted by the liquid at the base of the container? So the formula is P equal rho GH, where rho is the density given to us, H is also given to us 0.3, G is a constant, we know it is 9.8, so we just multiply it, get the answer, put the unit as Pascal. On this page we have some questions on buoyant force. We know that buoyant force is the upward force which acts on a object which is inside the fluid. So the first answer is buoyant force. It is just asking you to fill in the blanks. Upward force exerted by a fluid that opposes the weight of an immersed object, that is called as buoyant force. Next question, it's giving us the object's weight in air, which is 10 Newton, and then 7 Newton when you put it into water, as shown in the diagram. It's asking us to calculate what's the buoyant force on the object. So if you look at the diagram which is for water, we know that there will be two forces acting on the object. One is the force of gravity and one is the buoyant force which will act upwards. And therefore the net force we can calculate as Fg minus Fb. Why minus? Because they are in opposite direction. So 7, that's the net force which the balance is measuring here, 7 Newton. 7 is equal to Fg, which is given to us 10 Newton. That's the force of gravity acting on the object. That is 10 Newton minus Fb. When we calculate this, we get Fb as 3 Newton. Now you can also do it directly looking at the numbers 10 and 7. If 10 is the weight in the air and 7 is the weight in the water, that means the difference should be the buoyant force, which is 3 Newton. A block of metal with a volume 5 times 10 to the power negative 3 meter cube is totally submerged in a liquid, totally submerged in the liquid, so completely inside the liquid. The buoyant force is given as 50 Newton. So if it is totally submerged in the liquid, the volume of water which it will displace will also be the same volume as that of the block of metal. So you can see that I have written volume of water displaced is equal to 5 times 10 to the power negative 3 meter cube because it is totally submerged in the liquid, completely inside the liquid. And the buoyant force is given to us 50 Newton. We know the formula for buoyant force, rho of fluid times volume of water or liquid displaced multiplied by G. We just substitute the numbers which we have and we calculate the density of the fluid or density of the liquid, which comes out as 1020 kg per meter cube. Do not forget the unit, kg per meter cube. One last problem on this video. We have got 3 diagrams and we want to identify which one is sinking, which one is floating and which one is in neutral position. So in the first diagram, we can see that Fg is acting downwards, buoyant force is acting upwards, and the arrows are almost equal to each other. That means, not almost equal to each other. We can see Fb is smaller and Fg is greater. So Fg is greater than Fb, or I can say Fb is smaller than Fg. So it is being pulled downwards. That means F net is downwards. So the object is going to sink. How do I know that Fg is greater than Fb? By looking at the length of the arrow. I can see that these 2 arrows, the length of Fg is greater and the length of Fb is smaller. Okay. Then in the next diagram, we can see Fg, Fb again, and we can see that they are equal to each other. The lengths are equal to each other. That means the net force is equal to 0. That means the object will neither go up or down. It will stay wherever it is, and this is called as neutral buoyancy. So it does not move up or down, it just stays wherever it is. The next diagram, we can see that the gravity force is smaller than the buoyant force. And that means the net force is upwards. So the object will rise up and then start floating with some portion of it in the fluid. So in both the second one and the third one, the object will float. The only difference is in the second one, the object will float wherever you place it because it's a neutral buoyancy, whereas in the third one, the object will move up. Some part of the object will come out of the liquid and some portion will stay inside the liquid, so that the buoyant force and the gravity force can become equal to each other, and then it will start floating.